Hello all. So we are back. I'm just continuing the next part of light topic. So in last session, that is light part 1, we saw what is light, what is the properties of light, reflection, refraction, and then we saw the important law of reflection, that is your incident, your normal, your reflected ray lie on the same plane. Then we saw about the plane mirror. And then we saw both the different kinds of spherical mirrors, your concave and convex. We saw important parameters in that. And then we saw both the ray diagram governing both your convex and concave and the rules. Hope you all remember about that. So next I told you that we are continuing to the next part of the spherical mirror. That is nothing but you have six position, right? For the concave mirror, you have six position. That is, mirror will be it will be the center, and your object will be somewhere, right? From the particular distance from your mirror. So, depending upon the object where you place, absolutely you will have the corresponding image, right? So, depending upon the object position, okay, so the first position, if you keep it at infinity, so you don't know the exact position of the object, then you keep it at behind C. Okay, what is your C actually? Center of curvature. Do you remember? Yeah. And at C, exactly at C. Next is between your center of curvature and what is your F? What is your F? F is your principal focus, right? And then exactly when you keep the object at F, and then between F and what is this actually? This is pole. So a lot of students get confused in pole and principal axis actually. So principal axis is always denoted by what? XY, because it's an axis, right? So it is always denoted by XY, and your pole is only denoted by P. You should not get confused. P for principal axis, not like that. P for pole and for principal axis XY. So these are the six positions in which the object should be placed, and the corresponding image we'll obtain it. Right? So this is its position. So now we are going to see the now next we are going to see the formation of different types of images by concave mirror. So in the before slide, I showed you the six position, right? So we are going to see each thing separately. So what will be the first thing? An object which is placed at infinity. I don't know where is the object is, whether it is 5 centimeter, 10 centimeter, whether it is 15 centimeter. I just don't know. You know the name from the meaning infinity. It is somewhere. I cannot predict it, right? Okay. So how the image is formed? So this is the corresponding ray diagram, and this is your concave mirror. So you can see two rays, okay, which are named A and A. The two rays from the same point of the distant object. That is only called as a distant object. That is, infinity is called as your distant object. So the two rays from the same point, it is coming one ray which is striking your mirror, and the other thing is which is striking your pole. P stands for your pole, right? So the other one is striking the pole. So what happens is that the one of the ray which is going and hitting your mirror, like it comes and coincide through the focus F point. Can you see this? Focus F point, where the image, that is your A prime. So A is your from the distant object. A prime will be the image of the distant object. Okay. So the focus, and the other thing which is directed towards the pole also is coming and converging at the same point. Is coming and converging at the same point, which is considered as the image A prime B prime. This is your object at infinity. Can you get it? So when the two rays from the same point, but both are not going to the same destination, one is going to your mirror and the next point is going to your pole, but both are coinciding at the focus where you get the image. That is the image formed when the object is at the infinity. So, what is the characteristics of the image formed? What will be the characteristics of the image formed? So your image is real and inverted. And you know what is real? A real image is nothing but I can obtain in the screen. Okay. And inverted also I told you actually. What is inverted or laterally inverted I told you. So what is inverted? That is, I'll just recollect the last thing. So I just showed with the help of this example happy, right? So when you show to the mirror, literally, what happens is that the alignment or the shape of happy gets changed, right? So the left side go to the right side go to the left side. Only the left and right alignment is changing, but not the top and bottom. That is called as your inverted. Okay, so highly diminished actually. You have to agree to this point because you don't know where the object is. The object is at infinity. I can't predict the object at all. What will be the shape of the object? Nothing. Okay, so what the outcome of that object at infinity is, you will get a highly diminished image. I cannot see that. And it will be like a point size. What will be like a point size means it will be like this. Point size. That's all. Point size. Okay. So they are formed at your focus F. They are formed at your focus F. So the thing in the light lesson is you have to learn the ray diagram accurately. That is the point where the ray goes and strike, where you get the image. These two things you have to remember. So when the object is at the infinity, where do you get the image? You get the image at the focus. And the two rays, one is traveling to the mirror and the other is traveling to your pole, but both meet at the focus. So this is the important thing you have to keep in your mind. So when the object is at the infinity, you get the image at the focus. That's it. Okay. So that is your formation of different types of images by concave mirror. That is your one. The first position. What will be your second position is behind C. Behind C. So what is behind C means? This is your center of curvature, right? So behind the center of curvature, you are placing the object over here. See, AB is the object over here. Okay, and you are keeping it behind C. So what happens here is one ray. So you remember all the rules, no? In the beginning, I taught you all the rules. That is with the ray parallel to the parallel to the principal axis. Okay, what will happen? It will just go and the reflected ray will go to your focus. And the ray which is goes inside your center of curvature, it bounces back. It retraces its path. These are all your rules. Okay, so you have to be clear about your what rules. Okay, so behind C. So what happens in behind C? You are placing the object behind C. The one ray. Can you see this ray? The one ray which is parallel to your what principal axis. This is your principal axis. So when it goes parallel to your principal axis, what happens? Your reflected thing will pass through your focus where you get the image A prime. And the other ray which is passing through your center of curvature will retraces its path again. Can you see this arrow mark? Can you find the difference between this arrow mark and this arrow mark? So that is, this is passing through the center of curvature, and whenever a ray passes the center of curvature, it retraces its path from it. Okay, you get the image over here. So where the image is actually formed, it is in between the center of curvature and focus. So whenever you keep an object behind the center of curvature, you get the image in between the center of curvature and focus. So it is very simple. Okay. So what will be the characteristics of the image when it is formed between the center of curvature and focus? So it will be actually the same thing. It will be real inverted and it is formed between F and C, and it is also diminished. So what can we get practically? The image is also diminished in this case. Okay, got it. This is at infinity and this is behind C. So at infinity, where do you get the image actually? The image is exactly formed in the focus. And when you keep the, that is when the object is placed at infinity. And behind C, what happens to behind C? So behind C, you are getting it at what? Between the center of curvature and focus. The third thing is that when exactly you keep the object at the center of curvature. When exactly you keep the object at the center of curvature, right? So when exactly you keep the object at the center of curvature, what happens? The same principle. So a ray parallel to the principal axis will come and falls on the focus. The same thing when a ray passes to the center of curvature, it retraces its same path, the same rules. Okay, so what happens is that, see, here the object is placed in the center of curvature. AB is the object. Can you see the AB is the object which is placed in the center of curvature? So what happens is that a ray, can you see this? A ray parallel to the principal axis, okay, like it is going and checking the mirror, and it just passes through your focus. It just passes through your focus. There you get an image A prime. Okay, so I told you, whenever a ray passes through your focus, right? These are all your rules, kids. These are all your rules. Okay, so when I'm not teaching anything new here, it's all your rules, whatever we saw in the before session. Okay, so when a ray parallel to your principal axis passes through your focus. Okay, when a ray passes through your focus, what happens? The reflected ray will be parallel again to your principal axis. So when it goes, you can get the image A prime, B prime. Whenever it goes to the center of curvature only, it retraces its path. Whenever it passes to the focus, what happens? The upcoming reflected ray will be parallel to your principal axis. Got it? So what about the characteristics of the image? What about the characteristics of the image? This is also real and important. And what is the different thing here is, in the last two cases, we saw the position of the object, like a change in the position, right? So the object is not exactly formed in the object, the image is not exactly formed in the object position itself. You will have a change in position, but here it is not like that. So you have your image also formed exactly on the center of curvature position itself. That is the difference between the last two things, last two cases. And your object size will be same to that image size. The object size will be same to that image size. Got it? So this is at C. It's simple, easy. Okay. So next, you're placing the object between F and C. So you're placing the object between what and what? You're placing the object between F and C. So what happens here? See. So this is your F focus and this is your C center of curvature. You're placing the object. Here your object is. The same rule is only followed. So what happened is that a ray parallel to the principal axis. So what happens? It just passed through the focus. There you get the image A prime. Got it? And a ray, see, can you see here? And a ray, this one, okay. And a ray which passing to the center of curvature retraces its path again. Retraces its path again. So there you get the image A prime, B prime. So here you can wonder. So what happens is that it is inverted. It is real. Okay, it is real actually, and it is inverted. Inverted in the sense AB is here and here A prime B prime. I told you already. The orientation will vary, and the image is formed behind C. The image is formed behind C. Can you get the contradiction of the second case? Second case, when you place the object behind C, you got the image between F and C. So when you keep the object in F and C, you are getting the image behind C. Got it? But in this case only, you will get a magnified image. What is magnification? A sharp image, I can tell. That is your magnified image. Got it? So this is your case 4. This is what? Case 4. Next is your fifth case. That is your, I'm keeping at F, at your focus. So when I'm keeping my object at focus, like this. So when I'm keeping the object, at at F, like this, the same rule is followed. A ray parallel to the principal axis, it passes to the focus, and a ray which passes to the center of curvature retraces its path again. But in this case, I get my image at infinity. So whenever I keep my object at focus, I get my image at infinity. Okay, so what will be the thing? Here also the same thing, real and inverted. I get my image at infinity and it is highly magnified. This is your case 5. Okay, so next is when you keep between the focus and pole. So this is your object. Can you see your object here? This will be your object and it is placed between your focus and pole. So what happens here? The same thing is only followed here. A ray parallel to the principal axis, it just passes to the focus. See, can you see here? A ray parallel to the principal axis, it passes to the focus. An array which passes to the center of curvature retraces its path again. And in this case, you get the image in the back. This is your image. Okay, this is your image in the back side of the mirror. So what will be your thing is virtual. So virtual, it's a false image. You cannot get it on the screen, right? So virtual and it is erect. And it is formed behind the mirror and it is magnified. So these are the 6 cases when you keep the object at different position. Right, so when you keep the object at different position, what about the images at that particular position? Okay, so you need not memorize this. You have to be clear about the ray diagram. You have to practice it. Okay, you have to clear about the ray diagram. So, when, the ray parallel to the principal axis, focus. Then the ray, when it passes to the focus, the reflected ray will be parallel. When the ray passes to the center of curvature, it just retraces its path. Got it? That will be the 3 main parameters in drawing this ray diagram. Got it? So next will be the formation of different types of images by concave mirror. So we saw the thing in 6 cases. Okay. So for the simplification, for more understanding. Okay. So what they have given this, they have tabulated here. That is your position of the object. Position of the object, where you keep the object, and the position of the image. Then what about the size of the image? Then what about the nature of the image? Whatever we saw in the before ray diagram, simplified form in order to remember it. Okay. So what happened? You keep the object at infinity, case 1, and you get the image at focus. Next, it is highly diminished, point sized. Next, what is the nature of the image? It is real and inverted. Next, when you keep behind C, what happens? It is in between, your image is in between F and C and it is diminished. So, your nature of the image will be real and inverted. Next, you are keeping at the position C. The object is placed at the position C. The position of the image is also you are getting at C. So this is same size and it is also real inverted. Next, the position of the object is placed between C and F and your position of the image is formed behind C and the size of the image is enlarged. And it is real and inverted. When you keep at F, that is your this thing and this thing will correlate. When you keep the object at infinity, you get the image at focus. When you keep the object at focus, you get the image at infinity. Only the size of the image get varied and the nature of the image get varied. Okay. So here, when you keep the object at focus, so what happens? You'll get the position of the image at infinity, and the size of the image is highly enlarged. And what about the nature of the image? Nature of the image is real and inverted. Nature of the image is real and inverted. So when you keep the position of the object between your pole and your focus, so what happens is that the position of the image, you are getting it behind the mirror. You are getting it behind the mirror, and the size of the image is enlarged. Size of the image is enlarged, and the nature of the image is virtual and erect. And the nature of the image is how? The nature of the image is virtual and erect. So this is a simple tabulation so that you can recollect the ray diagram, corresponding ray diagram. So next is your uses of concave mirror. So we will have one doubt, where and all the concave mirrors are used. We are using it in our daily life. Okay. So where we can use the concave mirror, it is used in the shaving mirrors. It is used in the shaving mirrors. Next, torches, searchlights, and vehicle headlights. Can you see from here? Torchlight, like vehicle headlights. Used by dentists to get a large image. Can you see here? Can you see here? We are getting a large image of our teeth. Can you see it? Okay, so used by a dentist to get a large image of a patient's teeth. Next, in solar furnace, to concentrate heat, that is to keep all the sun rays to converge at one singular point so that the heat radiation will be maximum. So the solar furnace also they are using. So in day-to-day life, these are the application of your concave mirror. Next, we saw concave mirror, the 6 cases in the concave mirror, and the 6 ray diagrams we saw, and the uses we saw. And now we are going to see the same thing, image formation by convex mirror. But don't get afraid. This won't be like concave mirror. We'll just have only 2 cases. That's it. Okay. So here the same thing at infinity. So I am keeping my object. Can you see the object? The object is placed at infinity. So the object is placed where? The object is placed at the infinity. So when I place my object at infinity, what happens is that I taught you already. Do you remember? Convex will, what convex will do? It appears to meet. It appears to be done, but not actually. It's virtual. Okay, it's virtual. So what happens is the same ray. Can you see the ray? The two ray traveling and striking towards the mirror. It appears to, what happens? It appears to meet the focus. It appears to meet the focus. There you get the image. So what is the characteristics of the image formed? So it will be virtual and erect. Next, it will be behind the mirror at F. Next, it will be highly diminished. Next, it will be highly diminished. So you're getting the image behind the mirror. So this is at infinity. So when it is placed between infinity and P. So when it is placed between infinity and P, can you see from here? So when we place it like between infinity and P, this is your P. Oh yeah, this is your P, and this is the object which is placed at infinity. I can tell the object is not exactly placed at infinity. It is placed here will be your infinity. I. So in between this I and focus, your object is placed. Don't misunderstood. Okay, it is not placed at the infinity. It is placed between the infinity and the pole. So the same thing, a ray parallel to your principal axis. Okay, so what happens? It appears to meet the focus. The same thing. and then a ray which is passing to the center of curvature, it retraces this path. That also it appears to retrace this path. Everything is artificial, not true. Okay, so what happens is that you'll get a virtual and erect, and you'll get the image formation between pole and the focus. So whenever you keep an object in between infinity and the pole, you'll get the image formation between pole and focus. It is diminished. What will be the characteristics of this? It will be diminished. Only two cases. It appears to me. The same principle, it appears to me. But you have to keep remembering the position of the image. Okay. So next is where you use the convex mirror. Okay. So convex mirror are used in vehicle as a rear view mirror to see traffic at the rear side. We are using it in daily life, right? So, and used as a device to check thefts in shops. Can you see from here? Can you see from here? So it is also used as a device to just check the thefts in shops. Okay. Now we saw about for the concave mirror, what will be the position of the object where we place and corresponding portion of image. We saw 6 cases, and in convex we saw 2 cases. We also saw the uses. So now we are getting into the other thing. We are like we are heading to the other thing, other important thing, that is a Cartesian sign conversion. So we talked about the position, of the image and the object, right? So whether it is in left or a right or a bottom or a up. Okay, so what kind of conversion I should take it? Like this is very important when we go inside the numerical problems. Very short numerical problems. Okay. So what happens when the object is placed left to the mirror? Can you see here? Can you see here? This is your left side and this is your right side. So when the object is placed on the, can you see this wordings? When the object is placed on the left side of the mirror and the pole, this is your pole, and the object is placed on the left side of the mirror and the pole is taken as the origin. Okay. So the distance to the right of the origin, that is your, this will be your positive, right? Positive x-axis. While that this will be your negative x-axis, right? Okay. So the origin will be positive, while that to the left side will be your negative. And the distance above the principal axis, that is the above. So this is your principal axis when it comes to the above. So above the principal axis, that is your y-axis. So above the principal axis, that will be your y-axis is taken as a positive. But when you come below, the distance above the principal axis is positive, while those below is negative. Those below is negative. The right and the left, okay. So the right side is taken as a positive and the left side is taken as a negative, and the top is taken as a positive and the bottom is taken as a negative. So from that thing, we have a mirror formula for spherical mirrors. Mirror formula. Okay. So you need not worry about the derivation and all. So it is for the higher grade. When you switch to your 11th and 12th, you will be learning how this derivation comes. Mirror formula comes. But so far for the 10th, you can know only the formula. Okay, so the mirror formula is nothing but 1 by V plus 1 by U is equal to 1 by F. This will be your mirror formula. So 1 by V plus 1 by U, that is equal to 1 by F. What will be your U? U is the object distance. What will be your V? V will be your image distance. What will be your F? F will be focal length. Okay, so now the conversion only we are coming here. For convex mirror, your object, for a concave mirror, your object, where it is placed actually? Most probably towards the left side, right? Okay, so your sign conversion will be negative when you take the cases before slides. So image is normally obtained towards the right side of the pole. Okay, do you remember all those ray diagram? So it depends upon. So in convex, it is positive. But in concave, it is neither positive or negative. And the focal length for the convex mirror is positive. And the focal length for a concave mirror is negative. Okay, so the focal length of the convex, we'll deal this. We'll deal this last thing, but the first two things you're quite familiar. Okay, so the focal length for a convex mirror is positive, and the focal length for the concave mirror is negative. Okay, I'll tell you what is that. So here, magnification. Okay, magnification. So the magnification M. What is your magnification is? Oh, sorry, kids. I is missing over here. Sorry, excuse me. So the magnification M, it is nothing but it's a height of an image H2 by height of an object H1. So height of the image H2 by height of the object H1. So that is equal to image distance by object distance. That is equal to image distance by object distance. That is minus image distance by object distance. So for virtual image, that is for the false image, we cannot capture the screen. For that, your magnification is positive. For that, your magnification is positive. For the real image, your magnification is always negative. That is, when this magnification is greater than 1, the image is bigger than the object. Can you get it? So when the magnification is greater than 1, your image is bigger than the object. Okay. And when it is equal to 1, means it's the same size. When the object is placed at the center of curvature, you'll get the image at the center of curvature. So it matches for that case. When the magnification is less than 1, it is automatically understood. Your image is smaller than the object. Your image is smaller than the object. So the magnification is positive when your image formation is virtual and erect. And the magnification is negative. And the magnification is negative when the image is real and inverted. When the image is real and inverted. This is you have to know. That is why the magnification is taken positive when the image is virtual. When the magnification is taken negative, then the image is real and inverted. Got it? Real and inverted. Next is a refraction of light. So that is your bending of light. So the phenomena of bending of light when a light travels from one medium to the other medium. So in the last session, I told you like when the ray of light travels from air to water, it changes the direction of the path. It changes the direction of the path. So that is called as your refraction. So what is your law of refraction? All the incident ray, normal ray, refracted ray. There the law of reflection, all the incident ray, normal ray, reflected ray. Here what? This is also the same case. The incident ray, the normal ray and the refracted ray all lie in the same plane. So here coming into the important thing, that is your sin I by sin R. Can you see this? So that is the sine angle of I by sine angle of R. So I will be that is equal to one constant value where I is equal to the angle of incidence, R is equal to the angle of reflection and the constant that is equal to the refractive index. So what do you call as a refractive index is nothing but the velocity of light in one medium to the velocity of light to the other medium. That is whenever a ray of light traveling through air, it will have one kind of speed. It is understood, right? So when it is suddenly going to the other medium, it will not travel in the same speed. That will be the refractive index of the particular medium. That is called as your refractive index. It depends upon the speed of light and the medium what we are using. So what they are telling us, these two ratios depends upon the first medium and the second medium. Got it? Next is the refractive index. Okay, so what will be your refractive index? So the refractive index of a medium gives an indication of light bending ability. That's what I told in the last session. That is your last slide. Okay, so that gives an idea for us. Okay, when the ray of light traveling through air, it has one speed. So the same ray of incident light, when it's shafted to the water, it has different speed. So it gives an indication of light bending ability of that medium. So here can you see N21? This is only the constant value refractive index. That is, it is nothing but speed of light in medium 1 to the speed of light in medium 2. Okay, so you'll denote it as V1 by V2. And what is your N12? Speed of light in medium 2 by speed of light in medium 1. That will be V2 by V1. So this is only the main thing. That is your NM, refractive index. So speed of light in air by speed of light in any medium. Okay, that will be your C by V. Okay, so where N21 is the refractive index of medium 2 with respect to your medium 1. So refractive index of medium 2 with respect to medium 1. Got it? Next is, these are the different kind of medium we can use. Okay, so see, material medium. For air, the refractive indexes, these are all calculated value. That is experiment thing. We'll do in the lab. Okay, we'll do in the lab with the help of a prism. A prism, that is a mirror only. Okay, a glassy material. Okay, so the air has 1.0003 refractive index, and for ice it is 1.31, and for water which is 1.33, and for alcohol. Why these are all greens? Why these are all greens? Actually, 1.44, 1.33, 1.31, 1.003 is, we use it often. We use it often. The results was very nice. Okay, for the experiment. So next is your fused quartz, turpentine oil, benzene. You need to know this. Okay. And for crown glass, I told you no, in the laboratory we'll use it. And Canada balsam, rock salt, carbon disulfide, dense flint glass, ruby, sapphire, and diamond. These are all the calculated thing. We just observed in lab and they are tabulated here. Got it? So these are the different kinds of the medium we are using. Next is a refraction. So just now we saw the reflection by your mirrors actually. Okay, so now what we are turning into it, refraction or refraction by spherical lenses. Refraction by spherical lenses. So there are two types of lens. One is your convex lens, other one will be your concave lens. One will be your convex lens, other one will be your concave lens. So here you can see, this is your lens actually, concave surface, sorry, convex surface. And this is your concave lens. Can you see? It is just a thin inside and just bulged outside. Right? So that is your concave surface. That will be your, and this will be like bulged inside and thin outside. The opposite of that. Here for the concave, you can have a spoon as the best example. That is, the spoon will have the inner thing that is in a depth, and the outer layer will be very thin. Okay, that is only the difference between the two types of lens, the convex lens and concave lens. So the same mechanism, the same properties, the same thing, the same parameters, everything. Here comes an optical focus. There you call as just a focus in case of mirror. Here what do you call in convex and in concave, you call it as a focus, optical focus. Though the central point of a lens is known as its optical focus. Can you see? The central point of a lens is known as its optical focus. And a line passing through this optical center is the principal axis. Can you see? The line passing through this optical center, it is called as the principal axis. Okay. And the focus is the point where rays converge. Where rays converge. Can you see in the case of convex, what is happening? It is just converging at one particular point. But in concave, what is it doing? It is just up here to converge. That is only the difference between the mirror and the lens. Mirror and the lens. So they are opposite to each other. Here convex will converge. Here concave will diverge. Okay. And the important thing is that the principal focus. The focus and the line which is passing to the principal, like your optical focus, is only called principal axis. Got it? Next is your rules for drawing a ray diagram. Okay, so just now we saw all the rules from your mirrors, right? So in lens, you have a small change. That is, what will be your first rule is that a ray of light parallel to the principal axis passes to the focus after refraction. The same thing only. So a ray which is parallel to the principal axis passes to your focus. And what will be your second thing? A ray of light passing to the focus. What happens? You get a reflected ray parallel to your principal axis. Got it? The same rules only. Okay. So whenever a ray parallel to your principal axis, it passes through your focus after refraction. So whenever a ray passes through your focus, you get a parallel array to the principal axis after refraction. Third thing is a ray of light passing through the optical center, that is your focus point, goes straight without changing its path. Just now we saw. So when a ray which is passing exactly to the center of your lens will not undergo any change, like not converging, diverging at all. It will just go without any change. Got it? Got it so far? So, these are the things we saw. What are the things we saw? We saw exactly the ray diagram of your convex and your concave mirror, right? And then the examples where we use the concave and convex mirror. We saw the refraction of light. We saw the law governing it. We saw what is the refractive index and the important law, and then the different refractive index of different material. Then we talked about the lens and what are the rules governing when the ray passes through your lens. Got it, kids? And the next corresponding thing, no? The upcoming thing, that is the rules for drawing the ray diagram for lens, will just continue in the next session. Okay, kids? Thank you.